NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial. Today we're going to learn how to multiply radical expressions. We'll work through two examples step by step. Let's begin with our first example. We need to compute the product of the square roots. Root of 2/3 times root of 6 times root of 5/7 times root of 14 times root of 10. Let's solve this step by step. First, we'll use the product rule for radicals. This rule says that the product of square roots equals the square root of the product. So we can combine all terms under a single square root sign. We multiply what's inside each radical. Next, we simplify the expression inside the radical. We'll use the rule for multiplying fractions and integers. Let's calculate each multiplication step by step. First, 2/3 times 6 equals 4. Next, 5/7 times 14 equals 10. And finally, we multiply all the numbers together. 4 times 10 equals 400. So we have the square root of 400. For our final step, we simplify the radical by extracting the perfect square. We know that the square root of a perfect square equals the number itself. Since 400 equals 20 squared, the square root of 400 equals 20. So our final answer is 20. Now, let's move on to our second example. We need to compute the product of 2 times the cube root of a to the 4th power times b cubed, multiplied by the cube root of a square times b. Let's solve this step by step as well. First, we'll use the product rule for radicals again, but now for cube roots. This rule says we can factor out the coefficient and combine the cube roots. So we can write this as 2 times the cube root of the product of what's inside each radical. Next, we simplify the expression inside the cube root by multiplying the terms. When we multiply terms with the same base, we add the exponents. So a to the 4th power times a squared equals a to the 6th power. And b cubed times b equals b to the 4th power. So inside the cube root, we have a to the 6th power times b to the 4th power. For our final step, we'll extract any perfect cubes from under the radical. The rule states that the cube root of x cubed equals x. We can rewrite a to the 6th power times b to the 4th power as a to the 6th power times b cubed times b to the 1st power. Now, a to the 6th power times b cubed equals a squared times b, all cubed. So we can extract this perfect cube from the radical, giving us a squared times b multiplied by the cube root of b. Combining with our coefficient, our final answer is 2 times a squared times b times the cube root of b. We need to calculate the product of two radical expressions, 2 cube root of 4 times -3 cube root of 2. Let's solve this step by step. First, we'll use the property of multiplication. When multiplying expressions with the same root index, we can rewrite the multiplication as the product of the coefficients times the same root of the multiplication of the radicands. Next, we calculate the product of the coefficients. 2 times -3 equals -6. And inside the cube root, 4 times 2 equals 8. So our expression becomes -6 cube root of 8. Now, we can simplify further by recognizing that 8 is 2 cubed. So we have -6 cube root of 2 cubed. Using the property that the cube root of x cubed equals x, we simplify this to -6 times 2, which equals -12. Let's calculate the product of these two radical expressions, the cube root of 2b squared times the cube root of 4b to the 4th power. For our first step, we'll use the product property of radicals. This rule states that when we have the same index for both radicals, we can multiply what's inside the radicals together. Since both expressions have the cube root, we can apply this property. For step 2, we'll multiply what's inside the radical. We multiply 2 times 4 to get 8. And we add the exponents of b. b squared times b to the 4th power gives us b to the 6th power. For step 3, we can rewrite this in a different way to help us simplify. We'll rewrite 8b to the 6th power as 2b squared cubed. This will make it easier to work with the cube root. Finally, for our last step, we'll apply the property that says the nth root of x to the nth power equals x. In our case, the cube root of something cubed equals that something. So, the cube root of 2b squared cubed equals 2b squared. We need to multiply the 5th roots. 5th root of 3 times 5th root of 9 times 5th root of 3 over 5 times 5th root of 5 over 9 times 5th root of 27. To solve this problem, We'll use the rule that when we multiply expressions with the same index root, we can combine them under a single radical. Using this rule, we can combine all of the expressions under a single fifth root. So we get the fifth root of 3 times 9 times 3 over 5 times 5 over 9 times 27. Now, let's simplify what's inside the radical. First, notice that we have a 9 in the second term and a fraction 5 over 9 in the fourth term. The 9's in the numerator and denominator cancel out, giving us 9 times 5 over 9 equals 5. Similarly, we have 3 over 5 in the third term and 5 in what we just simplified from the fourth term. 3 over 5 times 5 gives us 3. So we have the fifth root of 3 times 3 times 27 times 3 times 27. Let's continue simplifying. 3 times 3 is 9, and 9 times 27 equals 243, which is 3 to the power of 5. Now we can apply another important rule for radicals. Using this rule, we know that the fifth root of 3 to the power of 5 equals 3. So our final answer is 3. Now, let's move on to our second example. We need to multiply 2 times the square root of a to the fourth power times b, and 3 times the square root of a squared times b cubed. To solve this problem, we'll first multiply the coefficients outside the radicals. So we get 2 times 3, which is 6 times the product of the radicals. Next, using our rule for multiplying radicals with the same index, we can combine the expressions under a single square root. So we get 6 times the square root of a to the fourth times b times a squared times b cubed. Now we need to simplify what times a squared times b cubed. Now we need to simplify what's under the radical by combining like terms. A to the fourth times a squared equals a to the sixth, and b times b cubed equals b to the fourth power. So we have 6 times the square root of a to the sixth times b to the fourth. We can rewrite the expression under the radical to see if we can simplify it further. Let's rewrite a to the sixth times b to the fourth as a to the third times b squared, all squared. This gives us 6 times the square root of a to the third times b squared, all squared. Now we can apply our rule for simplifying square roots of perfect squares. Using this rule, we know that the square root of a to the third times b squared, all squared, equals a to the third times b squared. So our final answer is 6 times a to the third times b squared, which simplifies to 6a to the third b squared. Let's summarize what we've learned about multiplying radical expressions. We need to find the product of the radical expression's cube root of a bc times cube root of a squared b to the fifth power c to the eighth power. To solve this problem, I'll apply the property of multiplication of radicals. When we have the same index on both radicals, we can multiply what's inside the radicals and keep the same index. Let's apply this rule to our problem. We have cube root of a bc times cube root of a squared b to the fifth power c to the eighth power. Using the multiplication property, we can rewrite this as cube root of bc times a squared b to the fifth power c to the eighth power. Now, let's simplify what's inside the cube root. We multiply a with a square to get a cubed. We multiply b with b to the fifth power to get b to the sixth power. And we multiply c with c to the eighth power to get c to the ninth power. Now we can simplify this expression further. When we have a radical with an index n, and the power of a term inside the radical is a multiple of n, we can extract that term from the radical. Let's apply this rule to our expression. We have a cubed inside a cube root, so a cubed comes out as we have b to the sixth power, which is 2 times 3, so we extract b squared. And we have c to the ninth power, which is 3 times 3, so we extract c cubed. Our final answer is a times b squared times c cubed. This is our simplified answer. Let's look at another example. Here, we need to find the product of cube root of a squared plus b squared times cube root of a to the fourth power plus 2 a squared b squared plus b to the fourth power. First, let's observe the expression carefully. We can recognize that a to the fourth power plus 2 a squared b squared plus b to the fourth power can be written as a squared plus b squared squared. Now, let's rewrite the original expression using this pattern. We have cube root of a squared plus b squared times cube root of a squared plus b squared squared. using the multiplication property of radicals, we can multiply what's inside the radicals. So we have cube root of a squared plus b squared times a squared plus b squared squared. Simplifying inside the radical, we get cube root of a squared plus b squared cubed. Since we have a cube root of something cubed, we can extract it from the radical. So our final answer is a squared plus b squared. Let's summarize what we've learned about multiplying radical expressions. Remember the key properties. 1. When multiplying radicals with the same index, multiply what's inside the radicals. 2. When a power inside a radical is a multiple of the index, you can extract it. 3. Always look for patterns that can simplify your work. Practice these techniques with different examples to strengthen your understanding. Calculating the cube root of negative 16. First, let's break down negative 16 as negative 8 times 2. We can separate this expression by using the property that the cube root of a product equals the product of the cube roots. So we get cube root of negative 8 times cube root of 2. Now, let's focus on the cube root of negative 8. We can express negative 8 as negative 2 cubed. Using the property that the cube root of x cubed equals x, we can simplify the cube root of negative 2 cubed to just negative 2. This gives us negative 2 times cube root of 2. Therefore, the cube root of negative 16 equals negative 2 times the cube root of 2, which we can write as negative 2 root 3 of 2. Let's move on to our second example, calculating the cube root of 54. First, we can express 54 as 27 times 2. Using the product rule of radicals again, we can separate this as the cube root of 27 times the cube root of 2. Now, 27 is 3 cubed. So the cube root of 27 equals the cube root of 3 cubed, which simplifies to 3. Using our power root property, we simplify to get 3 times cube root of 2. Therefore, the cube root of 54 equals 3 times the cube root of 2. Let's tackle our third example, calculating 2 times the square root of 150. First, let's break down 150 as 25 times 6. Using the product rule of radicals, we can separate this as 2 times the square root of 25 times the square root of 6. The square root of 25 is 5, so our expression simplifies to 2 times 5 times the square root of 6. Multiplying 2 and 5, we get 10 times the square root of 6. Let's summarize what we've learned in this video about calculating radical expressions. First, we use the product rule of radicals, which states that the nth root of a product equals the product of the nth roots. Second, we use the power root property, which tells us that the nth root of a value raised to the nth power equals the original value. By using these properties, we were able to simplify complex radical expressions into their most simplified forms. We need to calculate the cube root of 0.003. Our first step is to rewrite this expression. We can use the property that says the cube root of a product equals the product of the cube roots. So the cube root of 0.003 equals the cube root of 3 times 0.001. Next, we can separate the cube roots using the product property of radicals. This gives us the cube root of 3 times the cube root of 0.001. For the third step, we need to use the power property of radicals. The cube root of 0.001 can be rewritten as the cube root of open parenthesis 0.1 to the power of 3 close parenthesis. Now, we can simplify the cube root of 0.1 cubed using the power property of radicals. The cube root of a cubed value is just the value itself. So the cube root of 0.1 cubed is simply 0.1. Finally, we can rewrite our answer as 0.1 times the cube root of 3. So the final answer is 0.1 times the cube root of 3. Let's look at our example. We want to simplify square root of 128a to the 5th power. To simplify this radical expression, we need to apply the properties of radicals. First, let's rewrite 128 as a product of factors to find the largest perfect square factor. We can rewrite 128 as 2 times 64. And a to the 5th can be written as a to the 4th times a. Next, we'll use the property that says that the square root of a product is equal to the product of the square roots. So we can separate this as the square root of 64 times a to the 4th multiplied by the square root of 2 times a. Now we can simplify the perfect square factors. 64 is 8 squared, and a to the 4th is a squared squared. So the square root of 64 times a to the fourth becomes 8 times a squared. And we're left with the square root of 2 as the second term. Let's rearrange the terms to get our final form. We have 8 times a squared times the square root of 2a. This can be written as 8a squared times the square root of 2a. Our final answer is 8a squared times the square root of 2a. We've successfully simplified the original radical expression. Let's summarize what we've learned about simplifying radical expressions. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.